Okay, what we're going to look at today are two continuations of our rational expressions. The first one we're going to look at is what we call our complex fraction, okay? And a complex fraction contains one or more fractions in its numerator and its denominator, or both. So let's take a look at some examples of this. Okay. If we look at our first one, we have x plus 2 over 3x. So you see that the denominator has a fraction. Your second one here, we have 1 plus 1 over x over 4x plus 5. So you see that we have a fraction here. And our last one, we have x plus 3 over x and x plus 4 over 7x. So these are examples of complex fractions. Let's recall that the bar in our fraction, let's go back. Let's recall that the bar in our fraction represents what? Can you tell me? Represents division, okay? So we can simplify complex fractions two ways. We can go about it by using the division and simplify. And the other way that we can do that is by finding the lowest common denominator in the numerator and the denominator. So let's take a look at a couple of examples. Okay, we're going to start off with this equation. Write it down in your notes, please. We have an x plus 2 over x minus 1 divided by, remember your fraction bar also means division, x minus 3 over x plus 5. Okay? So the first thing we're going to do is we're going to rewrite. There are two ways that we can work these problems. I'm going to show you using that fraction bar, that division way of working these. So we would rewrite this as division. So now we have x plus 2 divided by x over x plus 1 divided by x minus 3 plus 5. So at this point, this is a division problem. This is back to what you learned about division. Division is the same as doing what? Multiplying by the reciprocal. So we rewrite x plus 2 over x minus 1 stays the same, divided by, now we have taken the reciprocal, so we flipped it, okay? We multiply those together. Actually, we would want to check to see if we have. If you want to go ahead and put your parentheses around them. Do we have anything that we can cancel here? Yeah, I don't see anything. So let's just then finish it up. We can bring them together here. And we could, if we wanted to finish it, we could finish it by using our FOIL to multiply that out. Okay? Okay, let's try another one. We have x plus 1 over x squared minus 1 divided by x over x minus 1. So again, we're going to consider our fraction bar being our division, so we are going to rewrite. We rewrite that as division. Then you treat this like you would a division problem. And, sorry, hit the wrong thing. You would treat this like a division problem, and you would take the reciprocal. So rewrite it. You also notice here you have an x squared minus 1. You need to factor that into its difference of two squares. So we've rewritten it. It is now x minus 1 over x. Now factor out that difference of two squares over here into that x minus 1, x plus 1 right here. And you can put parentheses around these if you want, because you know that they cannot be separated. Now in this case, we have something that can be factored, right? It looks like we can cancel out the x plus 1s and the x minus 1s. Now remember, when we do that, when we cancel out, they don't go away, they become what? They become 1s, right? So essentially, what do we have left in the numerator? 1 times 1 is 1 over 1 times 1 times x would be x, and there's your answer. Okay? All right, this next one we're going to look at is a little bit different. We are going to use our method 2 on this one. Okay, so I'm just going to kind of write that at the top, method 2. Take a minute to copy this down. 3 over x plus x over 2 divided by x minus 1 over x. Yes, we still assume that we do have, or that fraction bar, again, does mean division. But this one is a little bit different in that we have, if you look at the numerator, you see that you have 2 fractions. So we're going to go back to what we just got tested over, which was we're going to take, we essentially have 3 fractions, 2 in the numerator, 1 in the denominator, and we are going to find the common denominator for all 3 of these denominators. So we have an x here, we have a 2 here, and we have an x. So I know I need to represent the 2, and I know I need to represent the x. Now, I'm representing this x up in the numerator. Does that mean I also represent the x in the denominator? And the answer to that is yes. So we have for our common denominator a 2x. Okay, so now what we're going to do is we're going to go back and multiply every one of these fractions by our common denominator. Okay, so we have the 3 over x times the 2x plus the x over 2 times the common denominator of 2x, and the x minus 1 over x times the common denominator of 2x. Now, as you see on our next slide here, we will be able to cancel out. Your 3 over x, the x's cancel. Oops, sorry. The x's cancel out, so that would leave you with 3 times 2, or 6, plus over your next one, the 2's cancel, and that leaves you with x times x, or x squared. And in your third fraction, it is the x's that cancel. That leaves you with a 2. 2 times that x minus 1. Make sure you distribute that. That would be 2x minus 2. So let's take a look at that. So you have your 6 here. You have your x squared here. And here you have, distributing the 2, you have the 2x minus 2. Giving us a final answer of x squared plus 6 over the 2 times x minus 1. Or we can go ahead, if you want, and multiply that 2, distribute that 2 back in. So either one is acceptable. Okay, let's try another one of these. All right, here's the next one we're going to do. Copy it down, please. 1 over x plus 1 over 2x divided by x plus 4 over x minus 2. So again, just in that previous example, your numerator has 2 fractions, so we're going to go again with our method 2, and we're going to find the least common denominator. So if we look here, we have an x, and we have a 2x, and we have an x minus 2. Well, we know we're going to need that x minus 2 because you can't separate the x out of that. And then in the numerator, we have an x and a 2x. So I need the 2 and I need the x. Now, I do not need to bring another x over because in the 2x, that x will be captured in it. So there's our common denominator. So let's go now and multiply that through with all the denominators. Remember, you go ahead and have somebody pause in the video so you guys can write all this down. So if we go through and multiply through with that common denominator of 2x times x minus 2, we're going to go through the process of canceling all that out. Once you pause the video, cancel all those out and restart the video back up. Let's see what you got. Okay. In your numerator, the x, your first one, the 1 over x, the x will cancel. So that will leave you with 2 times x minus 2 to multiply out. And in your second one, it is the entire 2x that will cancel out, so you're going to be left with 1 times the x minus 2. And in the denominator, it is the x minus 2 that will cancel out, and you'll be left with the 2x that you will multiply through with your x plus 4. Let's see how that'll all turn out. So here's what we've got. Distribute your 2. 2x minus 4 here. No distributing on your second one, so you can just get rid of the parentheses. In the denominator, that 2x will need to be distributed as well. So that would give you 2x squared plus 8x. Giving us a final answer of 3x minus 6 over your denominator of x plus 4 times your 2x. Let's do one more of these. No, we're going to go ahead and stop at this point. I'm going to give you a few to practice, and they'll be out of the book.